Okay, well, it's 8:30 on Wednesday morning. We're kicking off the North Carolina GIS 2021 conference. I'm Alan Brock with GPI Geospatial, and I'm excited to be here, happy to be here, happy to be participating in a virtual conference. Um, Although I hope next year that we're participating back in person, because after a year of doing these virtual conferences and trying to communicate and network with people, it there's just so much we can do via Zoom and chats and computer screens. So hopefully we'll be getting back to the day very soon that we can do these things in person and have good networking and fellowship and together. I'm going to take a few minutes this morning as we begin this conference and sort of we're first out of the gate, but I'm going to take just a little bit of time this morning to tell you about GPI Geospatial and some of the things that we do, who we are, and talk a little bit mainly about mobile LiDAR. My colleague, Rich Wohlers, is doing a presentation a little later in the conference, I believe on Friday morning, talking about using mobile LiDAR and doing pavement analysis. So what I'm going to do this morning, after talking a little bit about us and GPI, Geospatial, and what we do, but just dive a little bit more, talk a little bit about mobile LiDAR and what it is and some of the capabilities that we have in that. So to sort of build a foundation for knowledge to build on with Rich's presentation. So GPI Geospatial, who are we? We are a geospatial firm. What is geospatial? Survey, mapping, GIS, anything having to do with the world we live in, mapping, showing location of places, things upon the world, topography, features, that sort of thing. So we are a full service firm providing traditional land surveying, remote sensing, aerial photography, aerial LiDAR from a mobile mapping system on the ground on a truck, and terrestrial scanning, along with the traditional surveying. And we also have a very strong GIS and development group to build on applications and help in that arena, which is what you guys would be more interested in. So quickly, I'm going to quickly, GPI Geospatial, we've been around since 1973. We began as Aerial Cartographics of America in Florida, in Orlando, Florida. We're purchased by Greenman Peterson, Inc. back in 2003. In 2017, IMC, Independent Mapping Consultants in Charlotte, was purchased and merged with GPI and ACA, and we became GPI Geospatial. So IMC had been operating in North Carolina and Charlotte for 20 years, beginning back in 2000, or actually 1997. So it was we have a long history of providing services, photogrammetric and GIS services through the years. As we continue, we look to continue for another 40, 50 years and continue to grow. Just quickly, where we're located, our offices, we've got 10 offices now in 7 states, with 2 here in North Carolina, 1 in Charlotte, and we have an office over in Wilmington. We're down in Marietta, Atlanta area, in Georgia, Huntsville, Alabama, 3 offices down in Florida, Locust Grove, Virginia, Columbia, Maryland, just outside of DC. And you can see we're pretty much in the southeast, and then we have a little bit of an outlier up in Sheboygan, Wisconsin. We've got a very large office up there with a very good staff of LiDAR and GIS specialists. So we're around, but we do still consider our North Carolina home due to the fact with the IMC connection and having been there in Charlotte for 20 plus years now. The thing we build on our strategic objectives for our company. Everything we do is based on these strategic objectives. And our number one objective always is our employees and employee satisfaction, producing a quality product. Client satisfaction comes in number three, which you would think, wait, client should always be first. But if our employees are happy, we're producing a good product, the client satisfaction will be there. And that, so it's sort of misleading, but it's all really about the client. And having good employees allows us to take care of you, the client. Having financial strength, managing our risk, continuing to manage towards our goals, and continuing to grow. So typical business objectives. Some of the services we offer, which is going around the wheel. Just quickly, we've got aerial photography, ground control, traditional surveying. Aerial, some of the photogrammetric processes of aerial triangulation, photogrammetric mapping, digital orthos. You do have some clients we work with providing volumetrics, airport mapping, and airport GIS is a big functionality, big area for us. Energy transmission and modeling is another area, very critical these days. We're doing a lot of work with Duke Energy throughout the Carolinas and throughout Duke service area. I think we're seeing, out in Texas right now, how critical the power grid is and how that power grid affects us. And so transmission energy and the power grid is going to be, I think we'll see a lot of activity in that area going forward. Asset management, they're surveying, building information modeling, BIM. We do a lot of scanning for interiors and Revit modeling and creating models for buildings. Our GIS component was up here, was sort of covered up, but again, I mentioned we provide services in that area. Asset management is one of the areas I was going to talk about for our mobile LiDAR system that we use. We do a lot of work for county and municipal markets and state DOTs with the mobile LiDAR system, collecting roadway signs and all the other roadway assets, as they call them, guardrails, poles, lights, traffic signals, and of course the signs, creating reports on those, not only the location, but building a database and reports of sign reflectivity and what type of sign, etc., that goes into those and the applications there. Sorry, I zoomed out too far. I wanted to get to our LiDAR. This is where I was going to talk about where, specifically I want to dive into the mobile LiDAR system a little bit and give you a little background on that LiDAR and how that operates. What is LiDAR? I'm sure most of you know that, with light detection and ranging. It's a laser used to take measurements, distance measurements, and then from calculating where the LiDAR sensor was and creating the distance and the angles, then collecting amount of taking those data points and measuring and creating data points either on the ground, on buildings, sides of buildings if we're scanning from the ground or from a mobile system, or on tops and creating topography maps from the aerial systems. We do have 3 aerial LiDAR units. We have 2 Regal 1560 Mark II aerial systems and an older Regal 680i that is 20 years old at this point and still going strong. So while the point spacing is not there with it that we can get with the newer systems, in certain applications, helicopter and low altitude, we can still get a very dense point cloud with that system. Our mobile LiDAR, we have 2 systems. They're Regal VMX 450 sensors, and then we also have the Regal static sensors for terrestrial scanning, our BIM modeling, bridge modeling, surveying under bridges and applications where we can't get to with the mobile systems. So again, the aerial photo here on the down the bottom left sort of gives you a picture of how the aerial system works. The beam of light sweeping the ground under the airplane as it flies along. The light pulse goes out, returns, and then we measure those returns up to 5 returns per laser point pulse. And each one of those returns could be typically the first and the last returns are top of in vegetation, the top of vegetation, and into the ground. But we also can get returns on the underbrush and undergrowth through the tree to create a very accurate model. And for vegetation analysis, veg management type applications, that is very helpful. Okay, let me get into the mobile system here and talk a little bit about it. You can see ours is mounted on a van. It's a dual head system. So there's 2 LiDAR units, each running at 750,000 megahertz per second. So 750,000 pulses, laser points per second coming out of these systems. So times 2, so 1 million points per second on the ground. When we're driving along, it allows us to drive at highway speeds, scan in a 360 area behind the van and collect roadway assets off to the side. We're good. Our distance collecting off to the side is typically about 100 feet or so off the roadway, which allows us to get out to the right of way most of the time on this. For our topo applications, roadway applications, we're getting repeatable results of 500ths, which is very critical when you get into roadway design. The engineers that are designing, especially as you can see in flat, low country area where drainage is just paramount and critical to the design, the crown of the road, that drainage and that accuracy is required. The DOTs require on most roadway 1/10 of a foot accuracy from the data clouds on the pavement. So with the proper planning and control, we can easily achieve that. For application developments, for asset inventory projects, typically we do those with minimal ground control using just the GPS. You can see there's a couple of GPS antennas and an IMU on the system. We can use that to have sub-meter grade accuracy without even, without ground control, having to place that. So a lot of our projects for asset inventory where that accuracy is not required, for that absolute accuracy, we will go in and collect it that way. And then when we need to, we have that data cloud. If they were to come back and say we need the roadway, we want the roadway, well, the accuracy of the data cloud itself within itself is still would meet that accuracy. So we would go in and tie down additional control to put that data cloud down to the control, and then could pull roadway design accuracy out of that lower accuracy cloud at a later date if required. So it's just sort of a quick rundown on the mobile system that Rich is going to be talking more in depth about in his presentation. Quickly talk about static scanning because that sort of goes in line with the mobile system and can be used to fill in holes along the way where we have bridge overpasses and things that we can't drive under to fill in the holes. And even sometimes with the LiDAR scans from the mobile system, which can't, there are areas of occlusion that are marked out and blocked by different things, beams or what have you. We can come in with the static scanner and set up and fill in those holes to create a complete model of a bridge. We use this system here is used to map internal, outside, inside of buildings. We recently did a project for Hartsfield International Airport where we scanned the entire inside of the main terminal building for them to do a upgrade to their plane train tunnels, and also to try to design and fit in some more escalators and elevators inside the building. Unfortunately, Hartsfield did not have a good idea. Their drawings and as-built data were very incomplete in areas, so they didn't know what they had. So we were able to go in and do a complete scan, interior scan of the inside of the terminal, back inside, out in passenger areas, and also in the secure areas, piping and mechanical rooms, and build complete 3D Revit models with asset information. We collected the tag information that they had, pipe numbers, types of pipe, conduit sizes, to build a model and asset inventory that they could then use to build and design their upgrades inside the terminal. But part of this, while we were working on this, we actually found there was a door that we had opened. It was a tunnel that they did not know existed. That it was not on any of their drawings. It was just a small access tunnel. So we were able to take the scanner off of the tripod, set it down in the tunnel, and scan that tunnel so that we could see how far it went and where it connected in on the other end to a different tunnel. So there's that type of thing. Sometimes you don't know what you're going to find until you get into it. And it was a very interesting project. Spent five people spent a month at the airport working every night from 11 p.m. to 5 a.m. scanning the interior of the building. And then from that 1 month scanning time, it took us 3 months to go through and build the complete Revit model and 3D model of the interior for them. And they've been working with that data, designing, and they're boring tunnels now to extend those plane trains. Quickly, just again, talk on the aerial sensors. Is the Regal Mark II 1560i sensors. For these sensors for ground, aerial applications, for your, ground systems, topo updates, countywide coverage, we can get from 4,000 feet above the ground. We're getting 40 points per meter on the ground from this system. So this really gives us, allows us to really, exceed 3-depth applications and provide really nice ground models and terrain models to go updating as we go forward, and as you begin to need updates in your Lidar data or your topography data. We own and operate our own aircraft. We have 2 single engines and a twin engine. Our twin engine aircraft has 2 holes in it. So with that aircraft, we're able to collect simultaneously aerial imagery, large format aerial imagery for the digital orthos, and collect the Lidar with that aircraft. Not many firms have that capability. So I don't want to go into all of these services. It's about 15 minutes in here. It's sort of the end of what I was planning to talk about, the prepared thing. I know we have the ability to chat and ask questions in the chat through our vendor hub. So I appreciate your time this morning. I'm happy to be here. We'll be in the virtual booth throughout the conference. I hope everyone has a great conference. If you have any questions, please reach out through the virtual chat, reach out to us at the virtual booth, or the old-fashioned way with email and phone. We're here for you. We want to support you and partner with you, and hope you have a great conference. Thanks for listening.
All right, thanks, Alan. And Alan, I'll keep you on. If anyone is in the session, just so you guys know, the chat button is the green button to the right of the session window. So just please use that function. You'll be able to chat with Alan. Otherwise, as I said, you can always reach out via email or check out his booth on the exhibitor tab.
Thank you.
Hey, Alan, there's a question.
Uh-huh.
I don't know if you've seen Attendee Hub. Robin asked a question. Was it 40 points per meter?
Yes. From the aerial, we can get 40 points per meter from the air at 5,000 feet. With the mobile LiDAR system, we're getting 1,000 points per meter or more.
Thanks, Alan. You're all set.
Thank you.
Have a great day.